Cool, okay. I think we're live. Yeah. Right. Oh God, it just closed. YouTube. Okay, nice. Tell me if I'm still audible, right? Otherwise, I will keep rambling.
Yeah, you're audible.
Cool. There's no need to moderate. Nobody's going to join in. How do I check where I'm streaming? Fuck. Do I just go to? Okay. Why am I not using the mouse? Yeah. Okay. 1 4 6 2 shit. Okay, nice. Let's go. Can I get a shareable link? Fuck yeah. And then somebody check and tell me if this is working. Oh, hell no, they're having a meet right now. Oh, who cares? All right. So what are we doing today? And why isn't Partho here? And sorry, what did you say? Could you say that again?
Can you hear me?
Yeah, I can. Yeah.
Let's go.
Yo, Partho, pull up, bro. Pull up to the stream.
I have to call.
Yeah, make it quick though.
Yeah.
Okay, he should be here anyway. Okay. Yeah, you fixed Spike. Right, let's go. Okay, let's have a look at what we have. Oh, that took a while to load. Here's Arsenite. Okay, actually, let's just clean this. Open up a team-up session. Get to Windows. Cool. Where should we start from? Let me just put this in the chat in case you guys want the resources to all of this. And let's get started at the lecture. Okay, so the way that a compiler works. Okay, yeah, by the way, this is how the session is going to be structured, sort of. I am going to be rambling about how a compiler works for the first few minutes, I suppose. So we're going to go over the lexer, then we're going to go over the parser, and under parser we are really going to spend, I think, a substantial amount of time learning what an AST is, and then we're going to learn what code generation is, and for that we'll have to understand what an intermediate representation is, and then we start programming. That's what we do. How does that sound? But yeah, that is the plan. And you might be asking, why was I so late to start the stream? Well, simple reason being LPG का price बढ़ गया. That might sound unrelated, but LPG का price बढ़ गया. See, LPG,
Understandable.
yeah, LPG price increase. That led to me not getting momos for the price I usually do. And that led to me being disgruntled, right? That made me eat at the mess, and I ate rotis, dal, and achar, right? Like pitiful
That's blasphemy, man.
I know, pitiful circumstances. Also, I was playing catch with the boys. Anyway, so all of this has led to the stream being postponed. But anyway, regardless, we finally get to start with the meat. Okay, lecture. What is the idea of a lecture? Well, the job of a lecture is to tokenize, right? You have a bunch of keywords, tokens, all sorts of things. Matter of fact, I'll show you guys what our programming language looks like. It says it's a procedure called main, which takes an count of arguments passed in, which is an unsigned 64-bit integer, and a vector of arguments, which is a list of strings. Keep in mind that strings in our language here is essentially just an array of characters, but we're going to flesh this out. We're going to allow for all sorts of operations on strings. Anyway, and it returns an unsigned 64-bit integer as well. And then we use the let syntax. We say that there's a variable called a of type u32, which is set to 3, and then same thing with b, and then same c is not defined, but it's declared. So we say c is equal to a plus b, and then we debug print this, right? Cool. And this is our starting point. What is the ending point then? Well, let's write the ending point so that we actually have an idea of what we are really going for. And to understand what that is, we are okay. Where did I put that thing? Num 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 num. Fucking hell. How should I? Let's try to open this thing. Work, Arsenite, resources. Cool. So let's have a look at the intermediate representation. So a compiler would have all of these steps, right? Now this code generation doesn't generally end here, right? It actually goes all the way over to assembly as well, which would require an assembler. However, we don't have that. I'm just not going to make that. Instead, we are going to output some intermediate representation, and QBE, a compiler backend, will take care of turning this IR into assembly. Okay? Is everybody on board with me till now? No, it is not JavaScript inspiration.
Yeah, pretty much.
Cool, cool, cool. We're going to really get into some examples, no worries. But first, let's get the starting point to the ending point. So before we run this compiler, we are supposed to start with this guy, okay, the main.at. And once we are done, here's what we're going to end up with. And the intermediate representation is going to be, actually, I should probably use LibreWolf for shit like this. I don't have LibreWolf? Okay, I do. Cool. Right. So this text here, right? This is not exactly assembly, however, you can shove it into QBE and it will turn this into its equivalent assembly, right? And QBE, if you don't know, it's very minimal. It's like really, really, really small. If you were to compare with LLVM, for example, LLVM is also another backend. So, matter of fact, let's do a slight experiment, right? Let's create a new Tmax window if I'm allowed to. Yeah. Let's go over to practice and then get IR probe and coin it. Cool. And let's write some Rust. Matter of fact, this is enough. This is enough Rust. Actually, let's skip the println. Let's just do let a type. Well, inferences work, so like I can just do this, and let's do this is maybe 9, and then there's b. No, fucking b is just going to be a plus b. Cool, and now we have some Rust code here, right? And now it's going to bitch that, oh, you have a variable that you are not using. Yeah, so what? Anyway, now there's this functionality that you will see, which is called Rust emit IR. You see this? Rust is actually like the Rust analyzer is like insanely cool because it allows you to have a look at the intermediate representation. Now, before we get into this, let me give you guys a little word of disclaimer. This is going to be quite complex, okay? Rust uses LLVM for the backend, and LLVM is quite complicated. It has type checking to like crazy extents. It's also very optimal. Weirdly enough, it doesn't have full ABI support for C. What that means is that a binary written in this would not be perfectly interoperable with a C file. That is weird, isn't it? Uh, Turns out it is that way. Anyway, so let's do Rust emit IR. Come on, bro. Anyway, so yeah, you see this? It has a ton of name mangling going on. I can turn on no mangle, but what essentially, oh wow. Geez, okay, it's using V tables. Of course, I'll have to explain that. V tables are essentially pointers, right? It's just a table that stores pointers to different functions, right? V tables are necessary for polymorphism. Um, which one of you can tell me what polymorphism means? Yeah, LLVM is a heavy motherfucker. Okay. Anyway, tell me what polymorphism is. Let's start with that. While somebody thinks the answer up, V tables are used for that. Um, yeah, this is borderline impossible to explain actually, since like, you know, it's so goddamn mangled. My God. But मुद्दे की बात ये है, right? Essentially, okay, finally, I think. Um, but what stands is that this IR later gets turned into assembly, right? So if I were to do Rust emit assembly, this is what we end up with, right? This is essentially then put into the assembler and we get a binary. Cool. All right. Now, different behavior of objects for different instances. Yes, a polymorphism. Yes. So polymorphism actually takes help of an idea that you can just make functions on the go, right? Yes, it can like behave differently. So you can have a function that can work with a lot of data types and it can like all of them have the same namespace in your text, right? In your code, but not in the assembly. So if you were to write some C++ code and if you were to take a look at the assembly for it, you will notice that you have multiple like if you made a class and then you like did some operator overloading or like whatever, right? You will notice that you get different versions of the function. Often what is done to get different names for these functions is name mangling. Name mangling literally means you take a name and you fuck it up to the point where it doesn't clash with anything. You know what I'm saying? Um, anyway, um, let's have a look at the QBE intermediate language. So all this to say that after our entire compiler thing does its job, we should end up with this. And now this thing we can pass into QBE, and QBE will turn that into an assembly file. And finally, we will be able to run it. Now, actually not run it, we'll have to put that into an assembler that will give us like things that will give us some object and blah, blah, blah. Mudde ki baat we have to get here. But before we make our compiler do this, why don't we do this ourselves, right? So that is exactly what we're going to be doing. Cool. So let's write the equivalent thing for this, right? So let's write the equivalent intermediate representation for this code on the left. In fact, if it is hard to see the code, I will just make it bigger. Actually, I'll make it a lot bigger. Okay, let's turn this into some QBEIR. So QBE requires, also QBE doesn't have types, okay? Which one of you can tell me what is the size of an integer on a 64-bit machine, for example? No, no. 4 bytes, yes. No, I was asking what is the size of an integer on a 64-bit machine? Yes, 32 bits. That is correct. Cool. So essentially what you do in QBE is that you don't bother about types, okay? At the IR level, you just, if it's an integer, integers will always fit into a word. A word is like 32 bits in a 64-bit machine, right? So, and how do I know that? I know that from the documentation, which is right here. Here you go. You have a word, you have a long, you have a single, and you have a double. Single and double are floating point types, and if you don't know how floating point types are different from an integer, you are going to have a look at IEEE, I don't know, 9 something float standard. 754, I think. Yeah, 754. This is maybe what you're going to have a look at. So, yeah. Essentially, floats are stored in a different way than integers. So even if they take up 32 bits, like, you know, a word and a single will take up 32 bits of space. However, they will be stored in a different manner, right? So that we have decimals. Get it? Anyway, so we're going to say export and then W main, actually, export function. And why are we saying export, right? So export is going to make sure that this main identifier, right, this main symbol, it is available even outside of the binary. Why is that necessary? Because every binary is going to need an entry point for it to be runnable. Otherwise, it's just an object or some sort of an ELF file. But we're going to need some way to get into it, right? Like start an execution chain. For that, we're going to take main and we're going to export this function. And then we're also going to say that main is going to return some type. We know that the type is going to be some sort of an integer, right? Matter of fact, main doesn't actually return an integer, right? Why is that? Because you see, it's a U64, it's an unsigned 64-bit integer. So what are we going to put in? We're going to put in an L, okay? Instead of a W, we're going to put in an L. Cool. And we're going to put in a bunch of this shit. So now, what should be the argc? We are going to say L, and we're going to name this something, right? It is 64 bits long, and let's just call this. And also, I will explain why I'm using dollar signs and why I'm using percentage signs. Don't worry about that. And I'm going to answer any questions that you guys have after I'm done writing out the intermediate representation of this guy, right? So L and then percentage argc, and we're also going to have an L arg v. Hey buddy, Partho is here, guys. Anyway, that, and then finally we can start writing the function. I'm showing them the intermediate representation for this thing, right?
Okay.
So that they have an idea of like what we start with and what we are hopefully going to end at. So we put in start, and then we start doing some stuff, right?
How are you implementing the debug print?
I'm just going to call printf. That's it. It's similar.
Okay.
We're going to turn debug print into a wrapper around printf. Anyway, okay, I think I have a question now. Okay, no, actually, no, I call me. Okay, Partho is a communist.
Okay, I see.
Right.
Yeah. From there.
Okay, what should I do?
Okay. এটা কি বলছে?
It doesn't seem to be doing
এখানে তো
anything.
আওয়াজ করছে।
কোথায়? Yeah, it is working then.
এখানে তো আওয়াজ করছে।
It is in fact working. That somehow fixes it, connecting the earphone again. Uh, Built-in analog stereo. I think I'm audible again. What I can do is that I can just say speakers. Unavailable. Wow, yeah, sure, of course. But it is worse. Right. Is this somehow? Alright, sweet. Okay.
They say it's better.
They say they do in fact say it is
It's
better.
the laptop microphone, right? Like the laptop mic is really good.
Functional dependency class test and DBMS did not do that shit fun. To run 15 kilometers alone out of space. What?
All right.
This guy, man. 15 steps. Yeah, Sarthak. Oh, no. We are professional recreational programmers today, aren't we? Yes.
Oh yeah, we are streaming.
Yes, we are streaming. I forgot. I truly forgot.
With the Zozin to
How is it going? It is Mr. Azozin. Anyway, cool. Now we have to somehow set things. Right. How do we set things?
It's your job.
We figuring things out today, you know. Ah, what is happening here? Okay. Hey, I'm learning things. Okay, guys, do not clown on me. I have to find a way to set something to something. If I don't manage to find a way to do that, I'll just Gemini. I'm a Chad like that. Is there a load? How do I check if this thing has a load? You know what I'm saying? I need to know if I can just
same page
add a different tag, I guess.
Just search, bro. Just search.
I can probably search load.
Like assignment search for it.
Maybe, yeah, maybe that would work.
That.
Okay. Hey, there we go, guys. We're moving again.
No need to waste like 2 liters of water.
It wouldn't be 2 liters of water. Maybach. Okay, you know what? No. Terrible ass. How do you also run 15 kilometers? Did he say that? 15 kilometers is insane. That's that. No. Acha. That's tightly stuff. YouTube, the compiler design community is in shambles. 4. Cool. And we're going to say %c equal to w add 3. Oh, no, not 3. Yes, in fact. A and B. Yes, sir. And finally, what we're also going to do is that we're going to do a W call printf.
What's the W?
I will explain to them. I have sort of explained it to them. I will go over it fairly soon. Okay, now before we get to print something, we need a string. How do we get a string? You may ask, or you may not ask, but I'm going to. So let's define a format string, right? Let's do fmt equal to, and we're going to do, it's a bunch of bytes. And I know that none of this is making sense. Don't worry, guys. I'm going to explain all of this because I'm the explainer, you see. C is
the camera on?
No, the camera is not on. C is this, and then this, and then remember, guys, strings always need null terminators, right?
Embedded into the
You got. You know why? It needs a pointer, not a literal. See. Yeah.
Null terminator is a literal.
Yeah. ওইটার কথা বলছি না. What I'm
No,
saying
like,
is that
if you do like slash.
yeah, you can do that.
Yeah, so why not do that?
I can do that, but like the examples did this. I'm a sheep. I don't critically think. Are you happy? অনেক দেখে নিছি.